All right. Hello, everyone, and welcome to the second meetup of the Tbilisi Data Science. Hello, David. How are you doing today?
Good. How are you doing?
Great. Yeah. Today, for the audience, we are exploring a particularly interesting topic that is the evolving world of retrieval-augmented generation and how this system is evolving with today's new standards. And I'd like to introduce our speaker for today, David, who is a senior AI engineer with deep expertise in building real-world AI systems. David, we're very glad to have you here with us. And yeah, the stage is yours.
Cool. Awesome. Yeah. Thanks for having me. I'm very excited to talk about today's topic. So we're going to talk about enhancing our RAG pipelines, and we're going to do that using MCP and multi-agent protocol, so agent-to-agent protocol. And we're also going to talk about reinforcement learning and how to unlock some cool, interesting data pipelines for our RAG implementations. So my name is David vonThenen. I am an AI ML engineer at NetApp. I've been in the AI space for some time. I, typically do a lot of NLP related stuff. So that's like natural language processing, but I have like a ton of other AI ML interests, like doing vision related projects, IoT edge related, edge AI related stuff, and then also building out like ML models to detect debilitating disease. Prior to that, I was in the Kubernetes and CNCF ecosystem, so I have a huge Kubernetes background, working on open source Kubernetes and everything in the ecosystem from observability and tracing. And then prior to that, I was in the backup and recovery space, so providing large scale backup solutions for virtualized environments, specifically VMware vSphere.
Lots of fields in the software engineering sphere.
Yeah, for sure, definitely. But it's good because, right, you have infrastructure background, obviously the AI stuff, and then talking about data pipelines. So so this is what we're going to talk about. This is the agenda. We're going to do a brief review of MCP and agent to agent, just to kind of level set, make sure we're all on the same page, kind of give a really high level overview. And then we're going to talk about the kind of the untold stories of MCP, things that you should be aware about. We're going to highlight a number of, if we're being critical about MCP, a number of like shortfalls or limitations. And then we're going to talk about how we can like expand on those and, look at other avenues for our data pipelines to make our RAG agents even more effective. And we're going to do that by driving a few demos. And then we're going to do the same thing for agent-to-agent protocol. Take a look at the criticisms for agent-to-agent, and then also kind of like how to address some of that and build on top of that, and then also drive that through live demos. So we're doing 4 live demos, so hopefully everything will be good. And then I'll have some resources. So everything that you're going to see here, including the slides and all the code, will be available for you to take a look at later on your own time. And then we'll have, hopefully have some Q&A at the end. So let's do a brief review of agent-to-agent protocol and MCP. So MCP, so Model Context Protocol, like just as a high level for those that aren't familiar with how MCP works, the way I like to think of it is it standardizes how you provide content to LLMs. And this could also be functionality where you're doing set operations like purchasing something online or that kind of thing. But kind of the like underlying implementation is you have a natural language interface to provide access to tools. And that could be tool access to read in data, or it could be tool access to do GitHub commits or purchase stuff on an e-commerce website. But at the end of the day, you have a natural language interface and you have APIs or SDKs that you're calling underneath your MCP services. So the way it happens and the way it works is your LLM is going to implement an MCP client, talk in whatever language that your domain is geared towards, and that client is going to call an MCP server endpoint. And that endpoint is going to advertise the capabilities and then also relay the interface for the functionality that you're providing. So that's like input parameters, what the output looks like, the function names, and a brief description of what it is. But effectively, MCP is just a unified protocol to connect tooling to your LLMs. So this is a great picture, and I use anytime I talk about MCP, I love to use this picture because I think it kind of like breaks down like what MCP is really at the root. So if you look in the upper right-hand corner, you see this Claude and MCP hosts, and that's effectively your LLM, right? OpenAI Claude, and it makes use of MCP clients. And the way I like to think of MCP, which is that center USB-C or USB bus, is it allows you to plug in a completely agnostic way to what the MCP server functionality is providing. So you can hook up different capabilities like accessing Gmail, accessing your local file system on your laptop, or even Slack. And so you can plug different things into this USB hub, which is MCP. And then you're imparting those capabilities to your LLM and your agent.
I see.
So now that we've kind of like briefly discussed what MCP is, let's talk about agent-to-agent protocol. And the easiest way, obviously based on the name, is agent-to-agent protocol allows for multi-agent interoperability. So agents that can communicate with one another. And there's many different pipeline or transports that are used to handle the communication. Default one that typically is used is server-side events, but there are different other mechanisms that are available as well. But kind of like the important takeaway for agent-to-agent protocol is that you can delegate subtasks to other agents that are better geared towards handling those particular tasks. So that's kind of like the big takeaway from it. And if you're looking to get more information about agent-to-agent protocol, it used to be a Google project, and it's an open source project, and it was donated to the Linux Foundation, and I've included the links in the slides here. But kind of the big takeaway is you have multiple agents that can talk to each other, delegate work to one another. And what's really cool is because we're talking about communication over like server-side events or JSON RPC, these agents can literally exist anywhere. So you could have them local on your laptop as long as it's accessible, talking to agents that are in SaaS service providers or even, in your hyperscalers. So what's really cool is that you have like a decoupled agent network, and they could be literally, these agents could be living and sitting anywhere. But the basic idea is agents delegating tasks to other agents. So what this looks like at the high level, this is kind of like your basic architecture diagram, a very simple one. What a typical deployment for agent-to-agent protocol and looks like. And so effectively, you have a client that comes in. It has a prompt or a question looking to answer a particular question. It calls into a coordinating agent, and then that agent then provides the coordination to the other agents that it might enlist to answer particular questions. So like as an example here, it would talk through agent-to-agent protocol, maybe to a summarization agent, maybe to a Q&A agent. And those agents themselves may be composed of different LLMs, maybe using MCP, but effectively, once all these subtasks get delegated, we get an answer to our subtasks. That coordinating agent takes the answers provided and rolls that back up to the client to provide the final answer. And that's kind of like what the high-level architecture and operationally how agent-to-agent protocol typically works.
A very good visualization here. It looks very easy like that.
Yeah, definitely. And we're going to take a look at an example of this in one of the demos, a very simplistic one. So yeah, we'll stay tuned and we'll see this slide one more time.
Great.
So why are we talking about MCP and agent-agent? So these are really kind of the building blocks of agentic AI. So we have AI agents. Typically, it's an LLM with the access of MCP to provide access to tooling, whether it's write operations or read operations. But those agents are kind of geared towards being subject matter experts, and they are built to work on a singular task, right? So purpose-built agents. And then using agent-to-agent protocol is where you can start to build out like agentic workflows, right? Enlist multiple agents in your network of agents and turn over the keys to like how to solve problems to this coordinating agent, or maybe delegating that how to plan something, maybe delegate that to a different agent. But kind of the point is you have a non-deterministic path to get to the answer. And in these agentic workflows, they all kind of follow these 3 things right here at the bottom. So come up with a plan, iterate over the plan, and then coordinate the final wrap up and messages between all of the different agents that are involved. So it's, analyze, adjust, and am I done yet? If I'm not, continue to iterate through the tasks that are in the list to solve a particular problem. And so that's where you have the memory involved, and then calling APIs through MCP. So this is kind of like what your basic building blocks for agentic AI looks like. So now let's talk about MCP. And these are kind of the untold stories and the issues that kind of exist with MCP. And then we'll talk about like how we can take a look at different ways of looking at MCP to enhance our data pipelines. So this came across a couple months ago, came across my Twitter feed, and I just, screenshotted and displayed it right here. But it's kind of true, especially in the early days of MCP, and it's definitely getting a lot better. But in the early days, earlier this year, believe it or not, people are deploying MCP servers left and right, and they had security holes all over the place. Especially if you had like multi-tenant or multi-user, like how do you know which user with which security context is calling what MCP and when, and what functionality are they exercising? And so this is kind of a look at like, you have to be very careful when you deploy MCP, especially if you're looking to deploy beyond a single user. You have to keep it in the security context and all this stuff in mind. And so I had a coworker who said, hey, what about, what are all the MCP security things that we need to be concerned about? And so I actually took that, made a prompt, fed it into OpenAI's deep research, massive prompt, and said, give me all of the problems, the criticisms that MCP has. And it turned out there's a huge list. And I'm not going to go through all of these today, but we're going, take a look at like the first one, for example, which I already kind of talked about. The way that an LLM hands off to an MCP server, there's a lot there, especially in a multi-user environment. It's very hard to see because we're non-deterministically turning over the keys to solving a problem to an LLM. How do you see who is using an MCP call? How do you understand when that call is being made? Does that call belong to a particular user? And so these are kind of like the list of things that you need to be concerned about when you're going to deploy MCP into a production type environment, especially in a multi-user, multi-tenant environment.
I see. And you mentioned, I think on the slide, it mentions the prompt injection attacks. Can you maybe give an example of like one of the prompt injection attacks that you've seen in the past, and if there was any fix that maybe others can also take in mind?
Yeah, definitely. So like prompt injection, there's many different ways of like taking a look at prompt injection. So most ones that people are most familiar with are like, hey, I'm providing a prompt, and within the prompt, I'm doing something nefarious or bad, right? Like a bad actor type situation. There are definitely other ones. So I've been reviewing MCP endpoints, and there could be other ones. And one that I've been taking a look at quite closely is putting in a bad actor MCP endpoint to try to get it to provide, prompt injection in the answer back to the LLM in the hopes that it invokes another MCP call with elevated permissions. So there's a lot of, different areas for prompt injection. And so it really depends on kind of what the thing is, but kind of at the end of the day, security, log everything, make sure you understand who's calling what, and then obviously try to shut down as much as you can. But like guardrails and stuff like that, in my opinion, will only keep, they're like locks on doors. They keep good people doing good things, but bad actors will try to figure out ways, and they will figure out ways around, getting LLMs to do stuff they're not supposed to.
Yep, I see.
So yeah, and the list continues. And if you want to see like the complete list along with the report that OpenAI had generated, and the one that I actually gave my coworker, you can click the link. When you get a copy of the slides, you can click that link and you can actually access that entire thing. Sure. Just a complete, I think it was like a 10, 15 page document listing them with examples of things you need to consider when deploying MCP.
Great.
So I know there's like doom and gloom, but MCP is quickly improving. So in June of this year, they added OAuth resource server integration, and so there's the RFC for providing secure authoritative tokens, protected resource metadata. You can still deploy MCP, which is what we're going to do in the demos here, because it is just a demo, not doing production. You can still do and deploy these things without any of this kind of security in mind. And then in the November release, which I'm not sure if it made it out, I hope it did, but there's improvements for doing task-oriented operations. So better help to do asynchronous type operations in a multi-user environment. So just be aware that things are improving, and as they improve, definitely, especially when it's security related, latch on to these security things and make sure you're implementing them. So, in the wild west of everyone rushing to deploy an MCP endpoint for their services, with all of these shortcomings, security holes and the stories that you're hearing are popping up everywhere. And I think one of the most, at least my favorite example, is the Replit vibe coding agent disaster. And I provided a link there to look at that particular news story. But basically, I believe he was the CEO, decided to use Replit to add in a new feature to their website, and the vibe agent, the vibe coding agent, was connected to a production server, production code, production database. And, there was a kind of like, the story is there was a misinterpreted error state. The LLM didn't quite understand what was happening. And in that misunderstanding, it deleted their entire production database. And I have this, the reply right here, which I love, is when the person who was vibe coding asked like what the heck happened. It basically was like, sure, it appears to be empty, and kind of like, I don't know what happened. And so kind of the big story is large language models, or LLMs, they don't have the fear of doing ridiculous, crazy stuff like deleting databases. And that's kind of like the big interesting takeaway from all this. But there are other example failures, like Anthropic's MCP O++ library, which builds out a lot of MCP type stuff. MCP clients and servers had a particular issue, in my opinion, they still do, where the session tokens were too easy to guess, and people were, hijacking other people's security context. And they decided to implement a fix using security through obscurity, so making the tokens much more difficult to guess. So just be aware of what you're doing, what you're deploying, and try to attack your own system, because you'll make it more secure that way.
Yeah, sure.
And then the last thing I want to talk about, and we'll tie all this together in a demo here in a second, is vector embedding limitations. And what's amazing and also kind of flawed is our RAG pipelines are usually only using semantic search, so vector embeddings. So we chunk documents, we provide them into a vector database, and the
traditional way.
Yeah, and it basically allows us to look at search for chunks of information relevant to a prompt over unstructured text. But because we're doing similarity, and otherwise it would be called exact search, so the limitations of that are, we're only doing a similarity search, and it's very difficult for using vector embeddings and semantic search to reason over multiple data points. What happens is we collect all the data points that look relevant and then use that information in order to answer a question. And so kind of the big limitation with vector embeddings is that there isn't a holistic view of the data. We don't know that a paragraph at the end of the document is relevant to the one at the beginning. And if you make a statement in the middle and you don't have the answer tied to the thing in the conclusion, you might be missing a large chunk of your information. So kind of the whole point of talking about this is that, vector embeddings, although they're great and they've revolutionized AI, they understand the limitations that they come with. And we're going to do a demo for this too in a second here.
Great.
So kind of now we've talked about limitations and things to be concerned about. Let's talk about enhancing our data pipelines with MCP. So what I think is a great opportunity is for read operations, especially with the context of OAuth. You can use MCP to access new particular sources of information. And because you have to log in, you can put them behind an access control list. And so kind of the big takeaway is when you fine tune a model, or if you're just using vector embeddings with a very simplistic model, all of that information that's either fine-tuned or in your generic source of your data set, that's general access data, right? Anyone can query anything that is being chunked in your RAG pipeline. But MCP gives you the opportunity to partition that data for access based on a user's access credentials. And the same is true for accessing APIs, right? If you have to log in, you can also use that security context to restrict like write operations for a particular user, and that can be fine-grained as well. So kind of the big takeaway in this first part of the session here is think about using MCP for providing data tiers and RBAC for API access.
I see.
And the other thing that I kind of lead in here is that this is using MCP is a great source for providing and obtaining new sources of data, right? Because if you can use your MCP server to read new API calls, access the internet, or whatever, you have the ability to now expand the data set that you have. And you can do that in kind of two ways, is like I like to think about it, is pull in new information if it's a trusted source. So if I'm building like a medical RAG agent, I can use PubMed, which is a public source for medical publications that are verified by other medical professionals. So you can include that in a trusted source trusted source of data, and you can store that. And then maybe you want to access the internet, and maybe that's not trusted because it's unvetted. So you maybe want to put that into a second tier of data. But kind of the idea is you can use MCP to also pull data in to your RAG pipelines. And there's a big reason why you want to do this. And I've included a link here saying that data right now, like most of the internet is like 50% generated by AI. And so we only have 50% of actual real new ideas being posted out there on the internet. And accessing these new real ideas might be a good way for you to increase your corpus of your data without ingesting some of this AI generated slop that's kind of happening these days. And so with that, we're going to do a couple demos demonstrating the reinforcement learning and kind of like why we need it in the context of MCP. So I've already, can you see my console here?
Yes.
Okay, perfect. So I've already ingested a data set from the British Broadcasting Company. So it's a large data set, 403 documents, relatively large. And it's already been ingested, and I'm going to run an I'm going to run a RAG pipeline based on the embeddings that are stored in OpenSearch. So we're going to create a RAG agent that's got a REST API on top of it. So you can see connecting to OpenSearch. I'm loading a small language model on my laptop here, and we're going to ask it a couple of questions. And so the first question we're going to ask, which I probably need to make this bigger, is how much did Google purchase Windsurf for? And so we're going to ask that particular question, and we're going to see what kind of response we get. And if you remember, Google ended up purchasing like Windsurf assets for 2.4 billion. So the assets and the people. And so hopefully in a couple seconds here, we're going to get a response. And so that deal ended up closing. And then I forgot who picked up the people. But yeah, so hopefully we'll get a response here in a second. And then the next question we're going to ask, which if you remember, a couple months prior, OpenAI was initially going to purchase Windsurf. And so as a follow-up question in a second, we're going to ask, how much did OpenAI purchase Windsurf for? And if you remember, like a couple months prior, OpenAI was going to purchase Windsurf for $3 billion. And let's see, is this going? It's probably because I've got a lot of things running on my laptop.
And which model are you using, by the way, here?
So I'm using a small language model. It's under 8 billion parameters, and it's by Intel. And it's also included in the list of resources in the README on the repo. So you can see the answer here. Google purchased Windsurf, 2.4 billion. So let's now ask that other question, how much did OpenAI purchase Windsurf for? And we should get an answer that says 3 billion. And yet both of these events didn't happen. And so kind of the problem highlighting about what vector embeddings is that we can see, right, OpenAI purchased Windsurf for approximately 3 billion, that it goes and searches the vector embeddings based on the context of the question, but it doesn't have any way to correlate these two data points in order to answer the question. So how do we fix that? So let's go ahead and use MCP as kind of a check, right? So I have an MCP endpoint, which is going to go ahead and access the internet. Oops. For additional news sources. And I'm going to hook up that server, our RAG agent, to our MCP endpoint, which hopefully you can see the client connecting right there. And we're going to ask that same question. Oops. How much did OpenAI purchase Windsurf for? And using the same vector embedding model and corpus of information, but accessing MCP, you can actually access the internet when we got a 200 request. And hopefully we'll get an answer in a couple seconds here. You can use MCP to access new sources of information, to maybe be an arbitrator or to pull in. And so here it says, I don't know the exact amount OpenAI purchased Windsurf for, right? Because they didn't. And the deal fell apart, and Google paid 2.4 billion for it. And here you can actually see, the MCP context that was provided. And so this is a really cool idea where you can use MCP to access new data sources, add this particular blob of information that we just pulled in through our MCP, and store it to maybe vet it to include it in the corpus of our information.
Yeah. It's a great implementation for sure, and great usage of MCP, as we could see from these examples.
Yeah, definitely. So let's see here. Okay, let's get back to slides. There we go. Cool. So let's talk about using agent effectively. And by doing that, we need to talk about maybe some of the limitations or some things we should be concerned about when implementing our data pipelines. And the first thing I want to talk about is everyone's talking about this new model, that Gemini 3 beats OpenAI's 5.1. These models are getting larger and larger. And as the models get larger and larger, it requires more resource, more GPU, a ton more GPU, a ton more memory. And while using them as a service is easy because you don't have to worry about the infrastructure, running them for your enterprise type applications may be a little more difficult, right? So
Yeah.
the reason why I'm talking about this is because these larger models have more memory. Yes, the data set's larger; it's trained on the world's information, but they also have the ability to talk about things that they might not necessarily should be talking about when answering a particular user's problem. So we have the kind of the big crux of why large language models hallucinate is that there's a reward mechanism to always provide an answer, and because you're
Exactly.
always trying to provide an answer, you're basically providing confidently incorrect or wrong answers, and that there's no reward for I don't know. And kind of like the way I like to think about it is which actually, if you noticed in our demo, it actually said, I don't know, which is very
Yep.
unusual for an LLM to do. But the way I like to think about it is think about going in grade school, right? Grade school, junior high. When you were taking a test, if you didn't know the answer, you guessed. And that's how I like to think about LLMs, right? If you guessed and you're wrong, doesn't matter. But if you guessed and you're right, you got extra points. And there isn't a mechanism to disincentivize I don't know, right? So that's kind of the big takeaway from that. If you're interested, I have a whole video recording about knowledge graphs and that, but kind of the OpenAI, Google, and Windsurf demo is to show exactly that purpose right there. So what could you do? So you could use a small language model. And there's the paper, which is the link at the top, a paper by Intel saying that you can use small language models. One, they're much better on memory. Two, you might not need to have a crazy GPU. You might have a medium, lower end GPU. Heck, you can even run it on CPU, which is what I'm doing on my laptop here. And the takeaway is that the hallucination rate's on par or better than a large language model. The inference is faster.
Okay.
And the reason why is because it has a much smaller corpus of data. So it basically understands language and maybe not too much more beyond that. And you can specialize your LLM, whether it's fine tuning or, vector RAG type stuff, to specialize your agent to do something specific to a particular domain. So this isn't one or the other. This is pick the best one for your task, but consider small language models for the I don't know factor. And kind of like the way I like to think about it is, if you're building out a financial system, there's no reason why it needs to know about basketball, right? And that's kind of like the way I like to think about it. Basketball, under swimming, it makes a lot of sense to reduce the knowledge set and then impart the knowledge that you actually care about onto your small language model, your language model.
And I think that's like most of the companies that are using AI, like in their companies, they basically have their own specific domain that they need to use it for. So like, why take the additional headache to like work with this large language models when you can just use the small ones with like more context to your own specific domain. So, but is there like any trade-off towards like performance and cost, or performance and like reward, for example?
Yeah, I mean, kind of the drawbacks for like small language models, right? If you haven't given the world's data set to it, right, you are restricted to like what you've imparted that information, and it will say I don't know if you in the prompt say that I don't know if you don't know the answer, right? So if you need to make a guess, maybe a large language model is better. And so that's definitely like a particular use case where like having a large language model could be better, but then you're now talking about running a large language model over the life of something just to take a guess. So, always consider like the drawbacks and the limitations for each, solution, right? And if you have the extra GPU and money to throw around, go for it, right? Why would you not, right?
Yeah, sure.
So like, why are we talking about, in this agentic world, agent to agent protocol? And kind of, we're talking about creating subject matter experts, or, agent AI agents that are geared towards one specific purpose. And this actually turns out to be a software engineering paradigm that we've been using forever, right? And it's breaking down problems into smaller problems, right? And then enlisting those tools to handle those problems. And so kind of like the whole point that I would like to bring to light and talk about here is using small language models and these smaller subject matter experts, imparting the knowledge that you have for that particular agent, gives you better answers, and it also helps decompose your problem and create modular agents, and then you have separation of concern, and it also fixes a number of other problems too. So, for example, when you have and you're using MCP, if you have a ton of MCP servers connected to one LLM, you have to describe the functionality for every function, for every input output, and then the description of the function for every function call for every MCP endpoint. And you can easily go through and completely blow out your context window because you're connecting all of these MCP endpoints to one particular server. So by creating like a subject matter expert that's geared towards one thing, so like a billing agent, for example, that only accesses the billing APIs, you cut down on like the MCP bloat because you're only accessing billing API calls, and then that agent can be reused anywhere where billing is concerned, right? So these things aren't new. I'm not talking about anything new, but they're old software engineering principles that we should probably consider taking a look at these days. And when you do have security problems, you don't need to go all over the place to try to find out what went wrong. It's isolated to the billing agent, right? And that's kind of like the idea for agent to agent.
Yeah, makes sense.
So remember this diagram. So we're going to do a couple demos here at the end, and we're going to go through an agent to agent example, and then we're going to a very simple one, and then we're going to do a far more complex one. So let's go ahead and take a look at that right now.
Let's see if the actual demo is as easy and understandable as this visualization.
Right. Hopefully it is. So let's do this right here. So I'm going to 3 agent system. I'm going to do a weather agent. So make weather agent. All this does, and it's hard coded, so it's going to do exactly. It's just to demonstrate how agent to agent protocol works. Weather agent that just reports the weather. It's been hard coded to say in Seattle, Washington, it's always raining, which is usually true. And then in Long Beach, California, which is where I'm from, it's usually always sunny. It only rains 6 days out of the year. So that's what that weather agent's hard coded to do. And I'm going to create another agent, which is a hotel agent. And this thing is going to provide recommendations to book hotels in particular areas. And in this window, we need a coordinating agent, something that we can provide our prompt to. So in this case, we're going to go ahead and create a coordinating agent that has a UI front end on it.
Okay.
And so this one I actually might need to exit out here. Excellent. Ooh, okay. And what we're going to do is we're going to say, hey, the very simple demonstration of agent to agent is I want to rent a hotel in Seattle, Washington. And kind of the prompt is, if it's raining, we don't want to book a reservation we don't want to book a vacation in a place that's raining and be stuck indoors the entire time. So we're going to go ahead and do that. And I think in the interest of time, we're not going to do this, the Long Beach one. You're just going to have to trust me on it, because this one does take a little bit of time. But the coordinating agent has policy built into it to say, hey, and it's actually using LangGraph. And it's basically saying, oh, here we go. Because the forecast includes hazardous conditions, it's raining, I'm not going to do recommendations for hotels. And if I put in the Long Beach one, it's obviously going to give me a list of hotels in the area that I can rent. So that's kind of the idea. Very basic, simple, simplistic agent to agent type demo here.
Mm-hmm.
So let's do a far more complex one. So you can actually see this is real because I'm going between directories here. Oops. Okay, here we go. Okay, so for our far more complex example, we're going to make use of that British Broadcasting news agent to basically provide us news for publicly listed companies on the NASDAQ. So we're going to create our news agent. And then we're going to create a financial agent. So this agent has an MCP endpoint, which we can use to access. That MCP endpoint was going to use a public platform that gets us stock ticker information. And so we can ask, hey, what's the stock quote for this particular company? So we're going to start that MCP endpoint, and then that MCP endpoint needs to be hooked up to an agent. So we have a financial agent. So we have a news agent, a financial agent, and then we need to start our agent-to-agent protocol for our financial agent and our news agent. So news agent.
And are those connections like per API request, or is it like through a WebSocket connection?
This one is, I believe it's using, what was it? I forgot the implementation. I think I've done this, at least the agent-to-agent part. I've done this a while ago. I think it's using HTTPS. It might be using WebSocket, if I remember correctly. Either that, so or it's using like a JSON RPC.
Great. So it's possible to like have the real-time data ingestion and the model working on those like live up-to-date data at the same time.
Yes, 100%. And actually, we're going to take a look at that here. So starting the agent-to-agent protocol for the financial agent. And then we also need our client, which is also going to serve up a cool UI, which is actually the same one. So if I go here and I do a refresh, yep. So you can see that we have a news agent, financial agent. And so let's ask it a couple of questions. And so what we're going to ask it is, based on the news articles, how much did Google purchase Windsurf for, right? Which we've all seen already, and hopefully it gives us somewhat the same answer. But kind of under the covers, right? What's going to happen is that our coordinating agent, which you should be able to see here, is going to ask our news agent, and it's going to grab the vector embeddings just like we did before and provide the answer. And notice that the financial agent's not consulted at all because it doesn't have any relevance to financial information. So if we go back here, and while that's actually working, I'll go ahead and grab the second question, which is, how is Google's, the ticker symbol, quarterly results for the last quarter? And this one does take a little bit of time. Yep, Google purchased Windsurf, 2.4 billion. And if we ask it Google's quarterly results for financials, you can see, got the financial information right here, and you can see that it consulted the MCP endpoint and then the agent that has that endpoint. So much more complex example, but this is an example of how you can decompose problems using agent-to-agent protocol. So that brings us to the end, and actually I have far more time than I thought. So resources for the session here in the presentation. Everything you saw, all the code, the slides, even the images used is provided in the right here, this GitHub repo for this meetup here. As an experiment, I'm going to try to do that this holiday break. If you're interested in working a problem together, so if you have a problem that you need help with, take a look and scan the QR code or just click the link here. And let's do a podcast together and like work through a problem. It could be something super simple, like how do I write better using AI? So if you're interested in doing that, hit me up. And I'd also leave you with these two other things, which are the links at the bottom, which is, there's a graph-based RAG. So we talked about vector embeddings, but there are other different implementations for doing RAG. And what it does is it replaces the R, the retrieve portion. So there are other methods for doing it. One is graph-based, and this other one I created just recently. It's a document-based BM25 that kind of gives you a weird hybrid RAG type feel, but not the full-blown RAG based on graph.
Yeah.
And there's actually a guide with all of the code available in both of these repos right here. So you can try those out as well. And with that, we have a ton of time for questions. Thank you so much for everyone's attention, and hope you found it interesting. And yeah, like definitely have time, good amount of time for questions.
Yeah, well, thanks, David. It was really interesting to go through these concepts at first, like theoretically understanding the mechanisms behind it, and also seeing the demo of it. Everyone who is in the meeting, you can write your questions in the chats, and we can go through them one by one if there are any questions. I think if I can kick off with questions. Like when we were going through these demos, um, like let's say when we are like in a small company, in a startup where like we have like tight budgets, like what are the like quick tests that you normally run to see like if the small model plus the RAG implementation that you're using is actually good enough for your model for your implementation?
Yeah, definitely. So like just like I did for this session here, like you can run, you can run large language models on your laptop, but you can also run small language models just using your laptop, nothing more than CPU. And so that's what I did for this demo. So if there are, mechanisms where if you like look in Hugging Face or wherever you're getting your small language model from, they have different versions for different quantized models. And so this model is quantized for int 8. So you can run them on your local laptop. And because they have different models where it's the full-blown unquantized model, you can run those with GPUs, and they usually do require them. But they'll have the full corpus because you're not quantizing and reducing down its vector type stuff. You can use those models on your laptop to test, right? And those will be good for the majority of the problems that you're trying to test out. And then when you start to scale up, if you want to run a model with a GPU, like the full-blown model unquantized, you definitely can, and you have a better sense that that model is going to perform just like it did in the the quantized version. So kind of like the roundabout way of saying is you can run your models on your laptop, go through the test cases and the use cases to make sure that you're getting all of the answers you think you should be getting. And then you can scale up to like the larger model. Now stay within the same family. It doesn't make sense to go from like the, Intel neutral chat, large language model to like Chat GPT, right? Because you're going to get wildly different answers. But using a small language model and then imparting that knowledge that you care about is a great place to start, in my opinion, because you don't need a GPU.
I see. Great. Yeah, that was all of my questions so far. And yeah, I don't see any questions in our chats. Hopefully, it was not too overwhelming. If like you guys have any questions in the future, you can contact David's for the consultation with these topics. Yeah, thanks again, David. It was truly an honor to have you here with us today. And I'm sure many of us are walking away with fresh insights, new ideas, and lots of motivation to basically explore these technologies further that you have showcased here. And we appreciate your time and expertise, and hope to stay in touch and continue collaborating in the future.
Yeah, definitely. And if anyone has any questions, or there's opportunity to talk about other topics, I'm totally game. I love geeking out on this kind of stuff. It's my favorite thing to do. So I'm always trying new stuff. But if anyone has any questions, feel free to reach out to me. I'm David vonThenen in all my socials, so you can reach out that way. But yeah, no, thanks for having me. It was awesome to be here. It's really cool to talk about some of maybe the more data sciencey, nitty gritty kind of stuff, and I love that.
Yep.
So yeah, thanks for having me. I appreciate it.
Thank you, David. Goodbye.
Yep.
Yeah.